Let's discuss simplified radical form. In order for an algebraic expression to be in simplified radical form, all of the following must be true. The first property that must hold is that no radicand contains a factor to a power greater than or equal to the index of the radical. For example, the cube root of y to the fifth would not be considered simplified, so this is not simplified. Because the power of the factor y, namely 5, is greater than the index of the radical, which is 3. The second property that must hold is that no power of the radicand and the index of the radical have a common factor other than 1. For example, the ninth root of x to the 12th would not be simplified. Because 9 and 12 have a common factor of 3. The third property that needs to hold is that no radical appears in the denominator. For example, 2 divided by the square root of 7 is not simplified. Because we have the square root of 7 in the denominator. And the last property that must hold is that no fraction appears within a radical. For example, the square root of 5 divided by 4 is not simplified. Because we have this 5/4 within the radical. All right, let's see an example of how we do put an algebraic expression into simplified radical form. Let's put this expression into simplified radical form, and we're assuming here that x and y represent positive real numbers. The first thing we should notice here is that the radicand contains factors raised to powers greater than the index of 4. We have the 6 as well as the 9. Since we are simplifying a fourth root, we need to focus on the perfect fourth power factors of the radicand, this 16x to the 6th y to the 9th. Now, something is a perfect fourth power factor when its exponent is a multiple of 4. So what do we have? We have the fourth root of 16x to the 6th y to the 9th is equal to the fourth root of 16, but 16 is 2 to the 4th power. And now we're going to extract the perfect fourth power factors here. So we're going to rewrite x to the 6th as x to the 4th times x squared. And we're going to rewrite y to the 9th as y to the 8th times y. And this is equal to the fourth root of 2 to the 4th, x to the 4th, x squared, and then we're going to rewrite y to the 8th as y squared to the 4th power, and then times y. Now let's group together all perfect fourth power factors, namely 2 to the 4th, x to the 4th, and y squared to the 4th. So this is equal to the fourth root of 2 to the 4th, x to the 4th, and then y squared to the 4th, and then times x squared y. And now by properties of exponents, this is equal to the fourth root of 2x y squared all raised to the 4th power, and then times x squared y. Again, by properties of exponents, this is equal to the fourth root of 2xy squared to the fourth, and then times the fourth root of x squared y. And now this is equal to the fourth root of 2xy squared to the fourth is 2xy squared. And then we still have this fourth root of x squared times y. So the question is, are we done? And we're not, because 2 and 4 have a common factor other than 1. So let's first split this up as 2xy squared, and then the fourth root of x squared, and then the fourth root of y. Now let's convert this term here to rational exponent form. In other words, this is x to the 2/4 power, which is x to the 1/2 power, or square root of x. Therefore, this is equal to 2xy squared times the square root of x times the fourth root of y, which would be in simplified radical form. All right, and this is how we put an algebraic expression into simplified radical form. Thank you, and we'll see you next time.